Okay, what I want to do now is I want to demonstrate how to solve for an equilibrium expression which is greater than a quadratic using a Casio in this case. So basically I've set up an ammonia decomposing into nitrogen and hydrogen. I've got a K. I've got it set here. I'm going to reset it. I'm going to say that the K is 50. And that's at 20 degrees. Again, you know, I'm just giving you examples. I'm making this up kind of as I go along. I don't know what the actual K is. But if I had a K of 50, then the way I would solve this, I would basically go, you know, build a nice table. Here's the initial concentration was I pumped in 5 psi of ammonia. I had no nitrogen, no hydrogen present. As it moves to the right, I'm going to lose 2x pressure units of ammonia. I'm going to gain an x for nitrogen. I'm going to gain 3x for hydrogen. So at equilibrium, it's going to be 5 minus 2x. That's the algebraic expression of the ammonia concentration, pressure, sorry. And then the x would represent the nitrogen pressure, and then 3x would represent the hydrogen pressure. Now when I set that back into the equilibrium expression where K is 50, so K equals this, I can plug in my ice table equilibrium algebraic expressions for these gases, and it looks just like this. And I can quickly see, oh, this is going to be bigger than a quadratic. I got x cubed and I got x squared. So now I'm ready to solve for x. Now on the Texas Instruments, you got to basically rearrange, but on the Casio you don't have to so much. So I'm going to see if I can set this up on the Casio. Turn this thing on. You can see that. For this, I am basically going to find my my solutions in the main menu. I'm going to roll over. There's a equations. So I hit equations. Sorry, my light went out here. Sorry. So now once I see here, I got F3 as a solver. So I'm going to turn on the solver. So now it's looking for the equation. So I'm going to enter the equation. Equation equals 50 equals. In fact, I'm going to expand this. This is kind of cool how much power the Casio has. It's kind of neat. I'm going to delete this for a second. I'm going to actually call this K for the K. And so I'm going to call it alpha K, H-I-J-K, equals, boom, boom, boom. And now for this one, for the equals, you can't use the regular equals. You got to look down by the space. You know, there's a dot or a period. And if you look up there above it, so if I shift, that gives me the equals sign. K equals, now let's enter this expression, alpha x. So we do use the alphas in this. Times 3x whoops, we better back up a little bit because we know that this is basically going to be 3 times x. And that expression is actually cubed. And then I'm going to divide it by, and again I'm going to put this in quantities. I'm going to go 5 minus 2 times x. Now I'm going to just change it up. I'm just going to put alpha x, and I'm not going to put the times in there. Show you that it has a little bit of capability to manage that. I'm going to square that in my parentheses. There's my equation. Now once I did that, it's asking for a k and an x, lower and upper roots. So what I'm going to do is I'm going to say in this case I want my k to be 50. I'm solving for that. And then what I'm going to do is I'm going to roll down and I'm going to say the lower. Again, I'm going to start looking at some reasonable small numbers. But we know here we're kind of limited. We can't lose more than 2.5. Now we're ready. And I'm going to highlight what I'm trying to solve for. So I'm trying to solve for x. And it says over here that if I push the F6 key, that'll turn on the solve. And there you go. The answer is 1.58.